Hey, pre-calculus students, we are starting Unit 3 on Intro to Trig. So you may have printed the interactive notebook pages. If you have, on page 30 in your interactive notebook, go ahead at the top of the page, glue in this blank circle. This is basically the unit circle. And we're going to talk about rotations being positive and negative, and then what terminal and initial sides of angles are. So every time you start drawing an angle, you're going to start from the positive x-axis. You're going to go in a positive rotation in a counterclockwise direction. So you're going counterclockwise or opposite of the clock. That is a positive direction. Whoops, that should be a plus. Positive direction. And if you're going in the negative direction, that's actually going to be clockwise. So negative direction is the way the clock goes. So that's this direction. And that's your negative rotation for an angle. So if you're given a positive angle, you're going to go counterclockwise. And if you've got a negative angle, you're going to move the angle clockwise. Now, initial and terminal sides. So let's draw these. The initial side of an angle will be along this x-axis. And I will highlight that in a red so you can see it. Okay, so that is always going to be your initial side along the positive x-axis. Now the terminal side, let's go ahead and I'm going to create some extra angles here. The terminal side is where the graph ends. So let's say that we rotate a positive angle around here. This side, and I'll highlight this one in blue, that is going to be considered or called your terminal side, or where the side ends. So the initial side is where it starts on the x-axis. And let's grab that so you can, let's grab this, there we go, the initial side. And then this terminal side is where this ends. Okay, whoops, it didn't copy it for me. Copy. There we go. Okay, now let's take it back up here and move our circle back. And now the picture is the way it should be. So we have a positive rotation that's going counterclockwise, a negative rotation that's going counterclockwise, an initial side of an angle, which is always in the positive x direction, and the terminal side is where the angle ends. So in this case, I've got an angle drawn in, and we're going to talk about quadrants in a minute, quadrant 2. So let's label our quadrants. Okay, quadrant 1 is your top right. All coordinates in this quadrant are going to be positive and positive. So if we have a point in quadrant 1, it's a positive quadrant. In quadrant 2, we know our coordinates are negative and then positive. So negative, positive coordinates. In quadrant 3, which is your bottom left, you're going to have negative, negative coordinates. And in quadrant 4, you're going to have positive, then negative coordinates. Now, as far as rotation of angles, okay, we know that if you rotate 90 degrees, let's do this one in purple. you're going to have a right angle. So the rotation up to the positive y-axis is 90 degrees. If we rotate around to the other side of the x-axis, that is 180 degrees. If we rotate all the way around to from the initial side, positive x-axis, around to the negative y-axis, that's going to be 270 degree rotation. And if we rotate all the way around the circle, that is 360 degrees of rotation. Now, we also have in the same positive, or in the same x direction, 0 degrees. So if you have a 0 degree angle, it's actually just straight out. It's the same as 360. So those are our positive angles. Now let's look at some negative angles. So if we're going to rotate a negative 90, it just means we're going to start on the x-axis and go backwards 90 degrees. So this 270 is also known as negative 90 degrees. If we have a negative 180, we're going to rotate all the way to the x-axis, but in the opposite direction. So this also represents negative 180. How about 270? So if we have a negative 270, we're going to go 90 plus 180 plus another 90. That's 270 degrees in the negative direction. So there's negative 270. And then what if we have a negative 360? We're going to start on the x-axis, go negative 90, negative 180, negative 270, all the way around. So this actually represents negative 360 also. So those are our positive and negative angles of rotation, our initial and terminal sides, and then how our quadrants, 1, 2, 3, and 4, and then how we create positive and negative angles from opposite directions. So let's sketch some. So at the bottom of page 30, you're going to go down and draw a circle, and we're going to sketch some of these positive and negative angles. So I'm going to go ahead and label my positive angles as 90, 180, 270, and 360. So when I go to plot this angle of 310, what's it going to look like? Well, this angle is going to start and go all the way around past 270 to here. So my angle of rotation ends here. So my initial side is on the x-axis. My terminal side ends in quadrant 4. That's your 310 degree angle. So sketch the picture and name the quadrant. So there's my sketch, and it would be in quadrant 4. Okay, now let's try a 270 or a 200 degree angle, negative 200. So I'm going to erase this. I'm going to leave the reference angles on, or the angles that are drawn on the unit circle. And now let's try a negative 200. So that means that I'm going the opposite direction. So instead of going counterclockwise, I'm going to go clockwise. So starting on the initial side of the x-axis, I'm going to draw 90 or negative 90, negative 180, negative 180 plus 20 more. That brings me to here. So there's my terminal side. So what quadrant is negative 200? It's in quadrant 2, right? Because isn't this 1 and then quadrant 2? And there's the drawing for a negative 200 degrees. Now let's try one that's greater then the unit circle are greater than 360. So what's that going to look like? Well, let's see. We're going to have to do a little math here and do some adding. So this is a positive angle. So my initial side always starts on this positive x-axis. I'm going to go 90, 180, 270, 360, but then I have to add another 90 again. So 90 plus 360 is 450. 450 plus another 90 is 540. 540 plus another 90 is 630. 630 plus another 90 is 720. So I've done 2 full circles and I still haven't gotten to 750. I'm at 720. So that means I'm going to go 30 more degrees and I'm going to stop, draw my terminal side, and that's the angle that represents 750 degrees. So what quadrant are we in? We're in quadrant 1. We went 360 twice, which was 720, and then added another 30. And that's how you would draw a 720 or 750 degree angle. So now let's try negative 700. Where is negative 700 going to land us? Well, let's start. Where do we always start? We always start on the x-axis. So a negative 700 would be negative 90, negative 180, negative 270, negative 360, negative 450, negative 540, negative 630, 630 plus another 70 is 700. So I'm in quadrant 1 again. That's quadrant 1. So I didn't go past 720. 720 is 2 circles, so it's a little bit short of 2 full circles. How much short? 20 degrees short of making 2 full circles. And that's how you would draw your negative 700 degree angle. Okay, now we're going to look at converting degrees between decimal version and DMS, which stands for degree, minute, second. So a degree will have the symbol with a little degree mark, which you're used to. A minute will have the signification of one little parentheses, and seconds have 2. So degrees, minutes, seconds. And it's just another way of taking an angle and breaking it into smaller parts. So 1 degree is like an hour. An hour has 60 minutes in it. And then 1 minute has 60 seconds. Therefore, 1 degree has 3,600 seconds in it, and it breaks it down to 3,600 tiny little parts. So if you say DMS, or that just means your degree, minute, second, we're going to first change it from a degree, minute, second to a decimal. Now to do that, we're just going to use our calculators. So this is just really calculator skills and knowing where these buttons are. So we have negative 2 degrees, 27 minutes and 4 seconds. So I'm going to type in negative 2. Now to get to my degree mark, I'm going to click my second function button and then the angle, which comes with the apps button. And notice the very first choice is our degree mark. So you can click enter. Now to get a minute, you're going to go to 27, same spot, second, apps, and the second mark there is one little parenthesis or one little mark, and we're going to choose number 2. Okay, now this is where it gets a little odd. 4 seconds. I'm going to put in 4 seconds, but the second mark is not under the apps button. It's over here on the plus button. So hit alpha, because it's a green button, alpha and plus, and you will get your second mark. Now, once you put your degree, minute, second in, just hit enter, and it will change it to a decimal for you. So it's negative 2.451 repeating, and we want the thousandth position, so 3 decimal places, 1, 2, 3, so it's just going to be 0.51 as our decimal. So negative 2, let's move this out of the way for a second, negative 2.541. Okay, let's try one more just so you can see the keystrokes for a second time. Okay, we're going to now convert 74 and hit second apps to get your degree mark. And then 8 second apps, number 2 this time. Oops, hang on. Second apps to get our degree mark, or our minute mark, and then we're going to get our second, so 14 seconds, which is now alpha, the green button, plus, and there's our minute, or our seconds, and there is our decimal, 74.13, and this will round to 7. So 74.137 is our final answer, rounded to the thousandths, and that is a decimal degree. Okay, now let's go the other way. Let's start with the decimal and convert it to decimal or degree minutes and seconds. So we're just going to type into the calculator our degree in decimals. So this one is 5.128 degrees. You don't have to put the degree mark, but we're going to hit the second and the apps button. And notice choice 4 is DMS. That is our conversion button. It will just convert it for us. So we'll hit enter twice because you're just defining what function you want. And it's 5 degrees, 7 minutes, and 40.8. Well, we're going to round the second to the closest second, so that'll be 41. So 5 degrees, 7 minutes, and 41 seconds. 5 degrees, 7 minutes, and 41 seconds. Let's do one more example, and then we'll finish up with this topic. So it's 34.817. And I want to convert it to decimals, minutes, seconds. So second apps, number 4, DMS, and our answer is 34 degrees, 49 minutes, and 1 second. So it's 34 degrees, 49 minutes, and 1 second. And that's our final answer. Hey guys, we're going to now look at complementary and supplementary angles. So you should be on page 33 of your interactive notebook. And we're going to take the notebook, this page, and kind of split it in half. The left side is going to be degrees. The right side we're going to cover tomorrow, and that's radian measure. But on the top of this page, let's go ahead and define what are complementary angles and what are supplementary angles. Okay, complementary angles are angles whose sum is 90 degrees. So in degree measure, 2 angles that add to 90. So some examples would be 40 and 50. Those 2 angles create a right triangle or a right angle of 90 degrees. Another one would be 20 and 70, or maybe 10 and 80. Those are complementary. Now, supplementary angles. There are two angles whose sum is 180 degrees. So you might have 80 and 100, or you might have two 90-degree angles. But it's any two angles whose sum is 180 degrees. Now, let's look at some examples in degree measure. So find the complement and the supplement. So you're looking for the partner. So what is the complement of 72? Well, I'm just going to take 90 and I'm going to subtract 72 to find the complement, and the complement is 18 degrees. Now to find the supplement, I'm going to take 180 and I'm going to subtract 72, and that leaves me with 108 degrees. So the complement of 72 is 18 degrees. The supplement of 72 is 108 degrees. Now let's look at 143. What is the complement? Well, what would I add to 143 to get 90? Well, since that is larger than 90 degrees, it does not have a complement, so it is not applicable. But we can find the supplement. So if I take 180 and I subtract 143, I get, what's that going to be, 37 degrees. So this one does not have a complement, but it does have a supplement of 37 degrees. Now on this page, notice I've got a line in the center. Tomorrow we're going to look at how to calculate that in radians. Okay, so now let's look at the second topic that goes on page 33. And typically we have a graph foldable that goes in here, but it's a little confusing, so we're just going to skip that and put our terms in. Okay, this one is a coterminal angle. They're angles that have the same initial position and same terminal position or sides. So they start and end in the same place, but they have different names. To find coterminal angles, you will add or subtract 360 degrees because it's just one circle around. So it might be looped twice to get there, but it's in the same beginning position and same ending position. So it's kind of like hands on a clock. As they spin around, they can have the same positions. Now, let's find a positive and a negative coterminal angle for 40 degrees. So I'm first going to just sketch what does a 40-degree angle look like and what quadrant is it in. So a 40-degree angle starts off the positive x-axis and it ends in quadrant 1. It's a very small angle. Now, I can have that same position if I start on the x-axis, I loop a full circle, and I go around to there. So what have I added? I've added a whole circle. So I'm going to take 40, and I'm going to add 360 to it. So a coterminal, a positive coterminal angle, would be 400 degrees. Now notice that's larger than one full circle, but it would be the 360 plus 40 more, which is 400. Now, what about a negative coterminal? Negative coterminals, we're just going to go the opposite direction. So I'm going to take 40 and I'm going to subtract 360 from it. Well, when I do that, 40 minus 360, that's going to give me a negative number. And that's correct because I'm going clockwise. So that's negative 320 degrees. Now, both of these angles start on the positive x-axis and they end with the same common terminal side, but we just get there two different ways. So there's a positive and a negative coterminal angle for 40. Now let's say we're starting at negative 120. So I'm going to just plot that. Negative 120 would be in quadrant 3. It's past negative 90. but not as far as negative 180. Now, to get to this position from the positive x-axis, a different way, I can take negative 120 and I can add to it 360. That will give me a positive coterminal angle of 240 degrees. And that makes sense because I would go, if I went the positive direction, that's 180 plus 60 more, and I would end in the same position with the same initial side and same terminal side. Now with a negative 120, if I want to get another negative one, I'm going to subtract 360. In other words, I'm going to keep going in that negative direction. So I'm going to start here on the positive x-axis. I'm going to loop once and then back around. So I'm going to add a negative 360 to that. So when I add a negative 360 and a negative 120, I'm going to get a negative 480. So there are two angles, 240 and negative 480, that have the same initial side, same terminal side, and they're called coterminal angles. Now let's try 540. Now we know, wow, that goes around quite a bit. So if I were to start on the x-axis and I were to go around once, that would be 360. Then this is 450, and then actually it ends over here at 540. So what's another name for that position? Well, since this is such a large angle, I'm going to have to subtract first to try to get it smaller because I've looped around more than once. And when I take 540 and I subtract 360, I end up with 180 degrees, which makes sense. That's this angle over here at 180. Now that's a positive coterminal angle. So I'm going to take that answer, 180, and I'm going to subtract another 360 to get a negative angle. So keep subtracting, and that gives me negative 180. Well, let's look at that. I would start here on the positive x-axis, go back, and yes, I would end at the same terminal side. So both 180 and negative 180 are the same terminal position as 540. And that's how you find coterminal angles. Now, on the same page, and if you run out of room, you can just label another page, 33. Again, it would be another flap on our foldable, but this one is reference angles. And for some reason, this tends to be the hardest one to understand. Okay, the smallest angle that the terminal side of an angle makes with the x-axis. So say that again, the smallest angle that a terminal side of an angle makes with the x-axis. And you can stop the video and write this down if you need to, but it's always positive, so you're never going to have a negative reference angle, and it's always less than 90. Okay, so it's an acute angle, meaning it's less than 90 degrees. So reference angles fall between 0 and 90. They are acute angles. I'll call this R for reference. It's going to fall between 0 and 90 degrees. Okay, so let's look at this little graphic, and you do have access to this if you want to put it in your foldable. So in quadrant 1, a reference angle is very simply itself. It's just the angle made with the x-axis. Now in quadrant 2, let's say you have a 120 degree angle. We're going to draw it with the initial side on the positive x-axis, the terminal side in quadrant 2. Now we're going to draw 120. We know that falls between 90 and 180. But the reference angle is this little distance back to the x-axis. So for a 120 degree angle in quadrant 2, the reference angle is 60. So what are we doing? We're taking 180 and we're subtracting the original angle to find the reference angle in quadrant 2. So it's 180 minus the given angle. Now in quadrant 3. Quadrant 3, again, starting on the positive x-axis, we're going to rotate around to quadrant 3. Okay, this is a little bit tricky because we know the angle falls between 180 and 270. So if the angle falls in quadrant 3, we're going to take the angle, in this case we're looking at 240, and we're going to subtract 180. We're going back to the x-axis that we've just passed. So how far past this x-axis are we? Always going back to the x-axis, or the closest direction to the x-axis. So this one also has a reference angle of 60 degrees. So in quadrant 3, you're going to take the angle itself and subtract 180. So I'm just going to put quadrant 3, you take the angle minus 180 to find the reference angle. Quadrant 4. Quadrant 4, we've passed 90, 180, 270, so it's some value between 270 and 360. Now, how are we going to find this reference angle? Well, we're almost around the circle, so we're trying to define this distance to get all the way around the circle. Well, how do we find that? We're going to take 360 and we're going to subtract the angle that we're given, and that is going to give us our reference angle. So let's say that our angle is 300. That falls between 270 and 360. If we take 360 and we subtract 300, we get a 60-degree reference angle. So again, the reference angle is always the closest distance to the x-axis, and it's going to fall between 0 and 90 degrees. Now over here on the right, you can see we've kind of color-coded it. So in quadrant 1, it's the green angle. Quadrant 2, it's the yellow angle going to the x-axis. Quadrant 3, we're going back to the x-axis, or back to 180. And then quadrant 4, you're trying to reach 360. So the reference angle is the measure of the terminal side of the original angle to the x-axis. So you're always going back to which axis? The x-axis. So let's look at this one. Okay, 280 degrees. We can use our rules up here. Well, 280 degrees falls in quadrant 4. So we're just going to take 360 minus the angle to find the reference angle. So take 360 minus the angle, 280, and that's going to give us 60 plus 20, that's 80 degrees. So we have an 80-degree reference angle. Now I'm going to draw it just so you can see it. Another way to look at this, if I start here on the positive x-axis, I go 90, 180, 270, 280. I've just passed this 270 by 10 degrees. Well, that makes sense. If this is 10 degrees, this has got to be 80 degrees. So that's our reference angle. Okay, so let's look at this one. This one's at negative 590. So we're going clockwise, and let's count it. 90, 180, 270, 360, 450, 540, 540 and a bit. This one's tricky because I've got to figure out how far past this x-axis we are. Well, if you count this as negative 540, because that's what we just counted it by 90s, right? 90, 180, 270, 360, 450, 540. How far past are we? We're 50 degrees. So the reference angle on this one is 50 degrees. So those can be the trickiest. So those are the three main topics for this part of the lesson. So let's just go back and flip through those very quickly. You've got your complementary and supplementary angles, where complementary add to 90, supplementary add to 180. Then you've got your coterminal angles. They're angles that have the same initial and terminal sides. So just different ways to name it, both positive and negative. And then looping an extra circle, so you add 360, or looping backwards, so you subtract 360. And then the last topic, which is reference angles, and is always the distance back to the x-axis, and that angle is going to fall between 0 and 90.